Everyone, welcome to Indian Online School. So today we are here to discuss few of our questions from grade 4 past SASMO paper. So this will be a demo for the SASMO upcoming exam. Hope this would help you. First question reads, the number in an unshaded square is obtained by adding the numbers connected to it from the row above. So basically the numbers below are sum or total of the numbers above it, and that too the numbers which are connected to it. What number must be in the square with the question mark? As we can see, the question mark is here. So we need to reverse calculate, because when we are adding, we are getting the number below. So we need to reverse calculate because we know the final total, that's 32. When you reverse operation, or the easier method of doing it is trial and error method. Since we have options over here, the first option says is 3. Let's try completing the figure with 3. If we just put 3 in place of the question mark, it should be 2 plus 3, 5, 3 plus 3, 6, 3 plus 6, 9 over here. Next, coming up should be 11. 5 plus 6, 11. 9 plus 6, it should be 15. 15 plus 11, 26. The final number comes to 26, but actually we should have 32. So that doesn't match. We can try up with our next number, that's 4. We can try up our next number, that's 4. If we just write 4 in place of the question mark, 2 plus 3 is 5, 3 plus 4 is 7, 6 plus 4 is 10. Next, 7 plus 5 is 12, 7 plus 10 is 17, 12 plus 17 is 29. So this again doesn't match. We can just try the third option. So this is called trial and error method. We keep on trying, and if none of the options match, obviously none of the above, option E is our answer. So the third option being 5, we can try it with 5. If you write 5 over here, 2 plus 3, 5, 5 plus 3, 8, 6 plus 5 is 11. Next, 8 plus 5 is 13, 11 plus 8 is 19. 19 plus 13, it's 32. Does it match? Yes. Hence, we can conclude that 5 is our required or correct answer, option C. Next, moving on to question number 2. The question reads, the given below is divided into 6 equal squares and shaded as shown. The given rectangle, this is a rectangle. If we see over here, it's shaded partially and it's divided into 6 squares. 1, 2, 3, 4, 5, and 6. 6 squares it is divided into. Over here, this line is not visible. Now we need to figure out what fraction of the rectangle is shaded. See, half and half, 1, 1.5, 2, 2.5. 2.5 squares are shaded out of 6 complete squares. We don't have any option as 6 as a denominator. So what we can do, we can just double it up. We just multiply it by 2. If we just multiply it by 2, what happens? 2.5 becomes 5 and 6 becomes 12. If the whole thing is multiplied by 2. So 5 by 12, yes, we do have an option as 5 by 12, option D. Hence, that's our answer. Moving on to the question third. Over here, we have a pattern question which reads 1, 4, 10, 22, 46, 94, and the last one is a blank space. We need to find for the blank space. So what we need to do, we need to first observe the pattern. If we just see, it's increasing by 3. The first one is increasing by, the first number is increasing by 3 over here. 1 plus 3 is giving you 4 over here. Next, 4 and 10, the difference is 6. If we just try to define it in terms of 3, it's 3 2 times. 3 2 times is 6, increasing by 6, giving me 10. Again, the next number is increasing by 10 and 22, the difference is 12. That means what? The difference is every next time doubling itself. It was 3 2 times, next it became 6 2 times, increased by 12. So 1 plus 3 was 4. Next over here, we had 4 plus 6, 10. After that, we had over here 10 plus 12, 22. Next, we should have 22 plus double of 12 is 24. 22 plus 24 is 22 plus 24 is 46. Next, we should have 46 plus double of 24, that's 48. That's 94. Okay. So next we should have double of 48. Double of 48 is 2 times of 48 is 96. So basically the next number should be 94 plus 96. If we add 94 plus 96, that's 190. Option A as our answer. Next question number 4. Amelia cuts a 75 centimeter by 30 centimeter rectangle into identical squares. Okay, so we have a rectangle. The dimensions to which are given to be 75 by 30 centimeter. So what's the area of this? 75 into 30. That's the complete area of the complete area of the figure. Now this figure is cut into identical squares without any leftover. So the whole figure is divided into squares, small identical squares, and there is no leftover after being divided. If the length of the square is a whole number, the length of the square has to be a whole number. It cannot be in decimals or something. What is the least number of squares she can get? Okay. See, what's the least number of squares she can get? 75 and 30. What are the factors of 75? 75 factors are 1, 75, 3, 25, 5, and 15. Similarly, if we just try to figure out the factors of 30, the factors of 30 are 1, 30, 2, 15, 3, 10, 5, and 6. Why are we taking the factors? Because factors are numbers which divide the given number. And over here, we have to do nothing but divide the rectangle. That is where we are finding out the numbers that can divide. Now, if we just observe the factors we have taken, if we just observe, the highest common factor is 15. To get the least number of squares, the size of the square must be maximum. Then only we can get the least number of squares. If we just keep on increasing the size, the more is the size, the lesser is the number of squares. So hence, if the HCF is 15, that means we can consider the size of each square to be 15. If the side of each square is 15, then the area of each square that we are cutting out is 15 by 15. The total area was 75 into 30. The area of one square that is being cut out from the entire figure is 15 into 15. So if we just simplify this, say 15 5s are 75, 5 3s are 15, 3 10 10. That means the number of squares, least number of squares you can get is 10, option C being the answer. Next, question number 5. 4 boys each prepared one gift for a party. There are 4 boys each preparing one gift, so 4 gifts. Okay, so 4 kids and 4 gifts. Now they have to just share these or distribute these gifts amongst each other in such a way that all 4 of them receive different gift, the one which they have not obviously prepared. So see, 4 kids and 4 gifts are there. If 3 of the gifts are being exchanged by 3 of the kids, obviously the 4th one will automatically get a different gift because all of them rest of them have already exchanged. If every people starts exchanging, so if 3 gifts are being exchanged by 3 kids, the first one taking up the second boys, the second one taking up the third one taking up the fourth. Obviously, 4th one do not have to exchange. The 4th boy will automatically get the first gift. Okay, so 3 gifts has to be exchanged by 3 kids. That's the permutation. 3 into 3, 9. So 9 different possible ways are there in which they can exchange their gifts so that they do not receive their own gifts. Next, question number 6. A number is formed by writing 2022 consecutively for 3 times. That means, how is it written? 2022. 2022, 2022. This is the number formed. 2022 written thrice consecutively without any break. Which of the following statements is true? Over here, the statements are all about multiples. So we have to apply the divisibility rule. So for applying the divisibility rule, we just need to know the sum of the digits first. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2 we have. That means the sum of the digits is nothing but 18. 18. If the sum of the digits is 18, obviously it is divisible by 3, 6, and 9, all three of them. Because 18 is a multiple, the number is a multiple of 3, 6, and 9. So the first statement itself is correct. Next statement says the number is a multiple of 3 and 6, but not 9. That's not true. That's not true because 18 is a multiple of 9. Similarly, the third is not true because it is saying not a multiple of 6. That's also false. Not a multiple of 6. That's again false. The first statement is correct that the number is a multiple of all three numbers, that is 3, 6, and 9. Next, question number 7. It is given over here. We have three figures as we can see: hen, duck, and let's say this is the dog, looks like a dog. Okay. So the third statement, three statements are given. First one, dog and hen together is 14. Dog, hen, and duck together is 33. If we just implement the third statement in the second one, that dog and hen together is 14. So dog and hen, over here in place of dog and hen, if we have 14, that means what's left for the duck? 33 minus 14, that's 19. That means the duck is 19. Now in the first statement, 2 hens and 1 duck, hen into hen plus duck is 100. Duck we just found out to be 19. So what's left for hen into hen? 100 minus 19, that's 81. Which number when multiplied to itself would give us 81? 9. That means the value of hen is 9. So that's our question. Option C is our answer. Moving on to question number 8. How many two-digit numbers are divisible by 3 but not by 6? How many two-digit numbers are divisible by 3 but not by 6? So we need to look at the multiples. The first two-digit number that is a multiple of 3 is 3 4s are 12. Till 3 3s are, we have a single digit number, that's 9. So 3 4s are 12. The first number that is divisible by 3 is 3 4 times 12. And the last number that's divisible by 3, two-digit number that's divisible by 3 is 333 times 99. 99 is the last two-digit number that is divisible by 3. So how many multiples did we cover over here? Till 33rd multiple, it shares two-digit numbers, eliminating the first three because starting from fourth multiple. So the first three are not there. So total 30 multiples are there, or 30 numbers are there which are divisible by 3. Similarly, if we just look at for 6, the first two-digit number divisible by 6 is again 12. 6 2s times 12. And the last is 16 times 96. Beyond 96, we do not have any two-digit number that's divisible by 6. So 6, 16 times. So till 16th multiple, eliminating the first one because it's 2 times, starting from 2 times. So hence, 15 numbers which are divisible by 6 and 30 numbers which are divisible by 3. So how many numbers which are divisible by 3 but not by 6? Obviously the difference, 30 minus 15. That's 15, because all the numbers that are divisible by 6 are automatically divisible by 3 also. That's the divisibility rule for 6. So 15 such numbers which are divisible only by 3 but not by 6. Hence option B, 15 is our answer. Next, question number 9. How many triangles are here in the figure below? How many triangles are here in the figure below? Okay, the whole figure itself is a triangle. So 1 plus how many small triangles we can just take? If we just take these two, half. So that's 2 over here. That's 2 over here. Okay. Moving on, if we just now start counting our smaller circles. If we just start counting our smaller circles over here, triangles over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 such small individual triangles, 21 triangles so far. Now combining two individual triangles, we can again frame up triangles. Combining two individual triangles, we can again frame up triangles. They are over here. So far we had 21. So this is 22. This is 23. This is 24. 25. 26, 27, 28, 29, and 30 so far. Okay, 30 so far. Now we can do it vice versa. We can do it the other way around also. We came up to down. Now we can do it left to right also. Okay, we had 30 so far. We had 30 so far. Now we'll do it the other way around, left to right. We'll keep it noted so that we don't forget 30 so far. Now, let's see, we have over here this one, 31. Okay. 32. Similarly, over here, 33 and 34. 35 and 36. So if we just take it sideways, we have over here 36. Do we have any more triangles? Yes, we do have 36 so far. Now, how we can take is, we can take bigger ones. 37, 38, 39. Over here, we have these three, 39. 39. Now, if we just take the triangles along the right angle, the triangles along the right angle, 39 so far. This is 1, 40. This is one more, 41. 41. This is 42. This is 43 over here. This is 44. This is 45. Along this, if we take, this is 46. And this is over here along this one, 47. So I hope we have covered all of them. We don't have any more. We have combined, we have taken individuals, we have taken 2, 2, we have combined 3, 3, we have taken the whole figure. So 47, option A, 47, that's our answer. Moving on to the last question for our class. Tyler plays a dice game in which he rolls 2 dice. His score is larger of the 2 numbers on the dice. For example, if he rolls 3 and 5, his score is 5. If he rolls 4 and 4, his score is 4. So basically, out of the 2 dice, whatever is the larger one, that's his score. He wins the game if his score is an even number. So what are the possible even numbers on our dice? 2, 4, and 6. 2, 4, and 6. If we consider 2 being the higher number, what are the possible outcomes? First dice having 1, second dice having 2. Both the dice having 2. First die is having 2, second die is having 1. We cannot have any more possible outcomes. So 3 possible outcomes are there. If we take 4 as the larger number, what are the possible outcomes? 1, 4, 2, 4, 3, 4, 4, 4, 4, 3. Because we cannot take 5 and 6, because in case of 5 and 6, 5 becomes the score. They are greater than 4. So we can take either 4 or less than 4. So 4, 3, 4, 2, and 4, 1. First die is having 1 and 4, second die is having 2, second one, first die is having 2, second die is 4. Again, the third possible outcome is first die is having 3, second die is having 4, and so on. So in this way, these are the possible outcomes where 4 would become the greater and the even number. 1, 2, 3, 4, 5, 6, and 7 possible outcomes. Similarly, if we consider for 6, 7 plus 3, 10 possible outcomes we have so far. If we consider 6 as the higher number, what are the possible outcomes? 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. We go again reverse, 6, 5, 6, 4, 6, 3, 6, 2, and 6, 1. That gives me with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 possible outcomes. We had 10 earlier, 10 plus 11, 21 possible outcomes. Hence, option C is our answer. That's all about the paper. Thank you so much.